Alright, so for this one here, we have an infinite geometric series, and this is your first term that was given. And we are finding its multiplier. So the rule is a sub 1 over 1 minus r. Over 1 minus r. So what we have here is we have that the a sub 1 is negative 3, and we're looking for r, but it's equal to negative 10. So we want to do a little cross multiply. Now remember, when you distribute your negative 10 there, you're going to change the sign on that one there. We'll put this one over here. We have 7 equals 10r. So we have just a nice little 7/10 here when we get our math. So again, you're just setting this equal to the sum. And you don't have to plug in an n or anything special for that. Now for these here, first of all, we want to figure out if it is finite geometric, finite arithmetic, or an infinite geometric. There is no infinite arithmetic. So for this one here, this is arithmetic. Let's go up. So we have finite arithmetic. And we're also going to do this one here, which is an infinite geometric. And so let's go ahead, well actually we'll do this one too. This one will be a finite geometric. We'll do one of each of them. So I knew it's geometric because it was a multiplier. I knew it's infinite because it goes up to infinity. I know it's finite because it goes to 5, and I know it's finite because it goes up to 20. So for our sum here, we want to find out how many pairs we have, which is 10, or 20 over 2. And then remember, you take the first term and the last term. So the first term is when you plug in 1 here, you get 5. And for the last term, the 20th term, when you plug in 20, you get 62. So we do that little math there and get 670. So let's look at this one here. This one up here. So these guys here, we have our first term and 1 minus r to the nth over 1 minus r. So I do need to know my first term, so I'm going to plug in 1 here. Now when I plug in 1 here, what happens is I get 1 minus 1. So we've never seen this before, this is brand new to you, but if you plug in 1 minus 1, you get negative 2 to the 0 power, which just changes into 1, a positive 1. So this here is actually my first term. So this is a very different setup than what we've been working with, but that's okay. We have our nice little 7 there, because I plugged in 1 to find out what happened. And then my r is negative 2. N is to 5th. And 1 minus a negative 2. So the denominator we'll go ahead and get is a 3. My numerator, I have negative 2 to the 5th, which gives me negative 32, but then I have to make that a positive because of this guy here. I'm going to have 1 plus 32 is my 33, and 33 times 7 divided by my 3 here. So we get 77 as our answer. Now, for the infinite, it's a little different. It's a sub 1 over 1 minus r. No n is necessary. And so our a sub 1, again, we're going to plug in a 1 here. When we plug in a 1, we get all of this to the 0 power, which changes that to 1. So it's 100. And 1 minus r is my multiplier, 7/10. So I have 100 over 7/10 less than 1 is just 3/10. So I multiply by 10 over 3 because I'm multiplying by the reciprocal, and I get 1,000 thirds as my answer.